Okay, so it looks like we're all to go. So let's get started. By way of introduction, my name is Mikhail Vladimirov. I'm with WebEdge Solutions, a company that provides a broad spectrum of regular and customized training classes in a variety of topics. So if you're interested in this particular topic, you can also approach one of your account managers or contact us directly. So we've got, yes, the link for the recording would be sent to you, I believe, later on alongside with the PDF slide deck. Okay, so I cannot tell you what the link would be. It would be generated automatically after this class. Okay, but definitely, if you have been on the original distribution list, you will be notified about the link. Okay, so that's our agenda. As I said, the class is scheduled to run for about 2.5 hours with some minutes after 2 hours. Let's see how it goes. You might have questions. I might have some discussion going on. I'll try to make it as useful to you as possible. But if you have very deep technical question, like how to deploy PCF on, say, cloud of specific flavor, Amazon, Azure, even though you can do it, there are lots of technical details. So your best option is to consult Pivotal documentation. In this class, we'll talk about Cloud Foundry, more specifically Pivotal Cloud Foundry. What is involved in activities related to moving to the cloud? So it's just kind of a big thing, and we will break it into pieces, and we will see what activities are involved in doing that. And we will touch on the 12-factor app methodology, which is a very popular way of designing your applications for the cloud. So big bullet items. What is Cloud Foundry? Cloud Foundry is a platform as a service. It's open source. There are certain proprietary extensions by those who would like to offer Cloud Foundry as their own offering to their clients, but the majority of the code without any enterprise quote-unquote extensions is in open source under Apache license. And as you know, PaaS platform as a service, I'm not going to cover all those topics. My assumption is that you have already been you have joined this presentation for getting something that you don't already know. So PaaS runs usually on some sort of IaaS, infrastructure as a service cloud, and that's what Cloud Foundry does. But the way it does it, it also provides through its own native cloud interface a way to run on a variety of flavors of clouds. It can run on Azure, Google Cloud Platform, Amazon, OpenStack, and others. Okay, so that's the major value proposition of Cloud Foundry, right? And Pivotal as well, Pivotal Cloud Foundry. So it makes it obligatory for you to comply with certain design and development principles. There are a bunch of those ideas, and some of those have been summarized into the 12-factor methodology. Here's the link. Right, and certain things just cannot be done without complying with those principles, right? And that's a good thing, because we are creatures of our own habits, and old habits, as we know, they die hard, and we need to some guidelines, and the stricter those guidelines are and enforceable they are, the better we are down the road. So history-wise, originally it was developed by VMware a while back now, and it has been transferred to that Pivotal software and there is a foundation behind it. It's kind of a, originally it was, if you remember that Spring Source, I think, with Rod Johnson. So essentially, eventually it just morphed into that platform as a service. So let's take a look side by side how you would compare the traditional on-premise IT stack, IaaS, and platform as a service. So with on-premise deployment, you pretty much manage everything. It's cumbersome, expensive, with respect to maintaining the hardware portion, keeping up to date with all the latest patches, performing the regular hardware upgrades, dealing with failing hardware, hard drives, network switches. With IaaS, things become a little bit easier because all the infrastructure, kind of fixed costs, are factored out, and you are exposed to all the details that you need to provide, to provision, to make your applications run in the cloud. So for that, you would have a middleware runtime network available to you through some sort of virtualized layer, some sort of API. You will be given a choice of virtual machines with a number of virtual cores, RAM, attached hard drives, and you can decide whether it should be like spindle, mechanical hard drive, or it should be SSD, solid-state drives. You'll have storage, networking. You can build virtual private networks. You can create firewall rules, pretty much everything, but all those things are virtualized. And somewhere behind it, there is a physical resource which can be swapped if there is a problem or if you would like to upgrade. But you feel yourself kind of more at home. You kind of you have eliminated lots of those things that prevent you from focusing on what you are supposed to do. Platform as a service on the right-hand side on the slide gives you a much kind of a more comfortable environment. It's kind of a I would say virtualized environment where lots of details have been abstracted out, like hidden from you, and you are focusing on your applications and data, how you save it, how you would like to retrieve it, and all the technical details, nitty-gritty details are hidden from you. Okay, and that's what Cloud Foundry does as any other platform as a service. You cannot hear me, guys. Can you raise a hand if you can hear me? Yes, Brahim. I believe that you might have some problem on your side. Again, you cannot hear me. The best way, I'm gonna send you a chat. Just give me a second, guys. Okay, just select. No, I cannot do that. I'm going to send to everyone. Sorry about that. Okay, guys. The question is, any vendor for IaaS-based model? Yes. Cloud Foundry supports all the major kind of mainstream IaaS platforms. Yes, it looks like only Ibrahim or maybe someone else cannot hear me. I send the chat in the chat window. That's the only way. Okay, good, guys. Ibrahim, sorry about this if you cannot hear me. So fix your earphones. Okay. So Cloud Foundry takes care of all those things, and essentially what they do, they create a layer on top of that IaaS platform. They've got cloud native interface, which allows you, it's like Java, if you are familiar with that concept. If you would like to access like memory directly, or maybe mess up with the underlying operating system, whether it's Linux or Windows, there is a JNI, Java native interface. Similar approach has been taken by Pivotal folks when they decided, you know what, the problem is there is no standards, lots of PaaS platforms, and we're going to talk about this shortly, but just to grab your kind of attention to set the backstage right. They decided to create that uniform, easy to use, intuitive, and quite powerful. So they expose some of the details that make you feel as if you are in control, but at the same time they serve you in the best possible way by providing servers, the runtime of your choice. And in some cases, you don't even need to specify that. I would like to run this on Node or Java or .NET. The system would figure out, or Python. We'll talk about this. This is the concept of Buildpacks. And storage-wise, is also exposed through some services. Networking is pre-built for you. You can customize things, but not very much. But that's the PaaS. You can create highly available applications. And what happens, you understand now that Pivotal and Cloud Foundry folks, they had to look at every IaaS vendor platform in isolation and see how they can best integrate. So probably it's my guess, my gut feeling that in certain cases, you have better support from them running a particular cloud flavor, because that particular cloud platform offers a better support natively. Okay, I cannot give you that information, but generally that's what it is. You cannot have one size fits all, and that's what they're trying to. Okay, Brahim, welcome back. You cannot really provide that kind of a one size fits all solution. Okay, so why would I need? I don't want to sound as, I don't know, like a salesman. I'm not associated with those vendors in any shape or form, but I see the benefits and I see some probably shortcomings, downsides. So let's take a look at what Cloud Foundry can give you. It's ideal, really, for those who would like to minimize the cost and complexity of configuring the infrastructure. We're talking about IaaS. And also, if you learn how to run your applications on Cloud Foundry or Pivotal Cloud Foundry, I will refer to Pivotal Cloud Foundry as PCF, then you pretty much have learned one trick, and you can just go to any place, any cloud, and with the same level of success, more or less, give or take, you'll be productive, and it'll help you in a number of ways. Right, so PaaS will help you manage things in a distributed manner, meaning that you can scale your application up, down, scale out to create additional instances. So Cloud Foundry or PCF, they are PaaS, even though they want to hide this kind of a thing as if it's just kind of somehow speaks badly of that. They just want to position themselves as a PaaS of a portable PaaS, platform as a service. So they use either virtual machines or container-based systems for deployment, and they promote the use of microservices based on 12-factor app principles. So that's a topic we are going to talk about towards the end of my presentation. By the way, now it looks like we've got more or less stabilized quorum. We've got the people we expected. So now I'm going to tell you that we're going to break for maybe 5 minutes at the top of the hour. 5-7 minutes so that you can attend to, I don't know, some day-to-day chores of yours. So Cloud Foundry is IaaS independent, and that's a true thing. It's kind of, again, as a virtual machine running on the cloud. It's like .NET or Java or any other runtimes, like maybe Python runtime. All the intricacies, all the details of running on 64-bit architecture, 32-bit architecture have been taken, or flavors of all operating system have been taken care for you. That's what Cloud Foundry offers you. I mentioned that cloud provide interface and CPI, and here's the more important cloud vendors that Cloud Foundry supports. So VMware's vSphere is also supported. So what are the intangible benefits? First, you avoid that much dreaded vendor lock-in scenarios, because you are not required to rewrite your application. If you have written it in any of the languages, it might be Python, it may be Java or .NET application or Node application, then you don't need to rewrite. So if you would have found some issues with the underlying cloud vendor, cloud vendor A, and you would like to move to cloud vendor B of IaaS platform, you can just take that thing, kind of lift and shift, move it to that new cloud, and you'll be fine. So you need to deploy Cloud Foundry or PCF, right? So it's essentially just a set of services. It's a pretty kind of a heavy, like big footprint, lots of services. But when you do so, it's probably will take you maybe, I don't know, like 2 days or maybe like 24 hours if you would like to work around clock. And then you have that application, that platform, that application of PCF or Cloud Foundry deployed on the target IaaS. So that lift and shift type of migration, it's just holy grail for many companies who don't want to spend too much, and they would like to have that flexibility and avoid vendor lock-in. So you need to understand one of the principles that doesn't sit very well with lots of folks who have been in IT, and particularly in the enterprise space for a long time. The immutable infrastructure principles is just a way to view VMs, containers, and pretty much runtime infrastructure as temporary, ephemeral entity. Meaning that when you shut it down, or if it gets killed for whatever reason, you kill it, or it gets killed because of some underlying hardware problems, your application would be recreated, or you would deploy it again, but pretty much all the state that you might have had, like maybe some files sitting on the file system, or things like that, would be just wiped out. And in certain cases, you can do certain kind of a clever hacking. You can preserve that. You can pretty much achieve that goal of going back to that original mentality that we would like to have everything on the machine. But then when you deploy it, and the deployment scenario might reshuffle your application. It might, that state that you have preserved might play some nasty tricks to you. So for that reason, immutable infrastructure principle, which is professed and followed by PCF and Cloud Foundry, you should avoid and you should treat that infrastructure as temporary. So you don't need to update your applications in place, and the infrastructure would spin up a VM or container, and it would deploy it automatically, so that you would need to pretty much create that baseline state of your application at runtime when you bring up your application. There is a number of things that can help you with that. We're going to touch on some of those when we will be discussing the 12-factor app. So it has some major repercussions for your application design, because one of the basic principles that people have been struggling for quite a long time, it's just maintaining the state. How would I maintain the state? The quick solution is just to externalize the state in the external storage. That's it. Which would be persisted, which would probably be something that is exposed to you by the underlying IaaS, rather than going through a layer of abstraction offered by PCF. But that is specific for your own solutions. So state shouldn't be preserved on that instance from which you run your application. It should be externalized. Or it should be injected in some way or another, kind of a dependency injection when you need it. So Pivotal Cloud Foundry is a certified commercial distribution of Cloud Foundry. So there is a Cloud Foundry Foundation where you can see folks like IBM, HP, Microsoft, kind of a big, high-profile, big players. And they have created the certification program where you can submit your own version or distribution of Cloud Foundry, and if it complies with certain criteria, then you can go ahead and offer it as a commercial software bundle. So PCF probably was the first one to be certified, because they created this certification program, and they are pretty much the main force behind Cloud Foundry. And they position themselves as enterprise flavor of Cloud Foundry. And for that, what they do, they offer a number of additional enterprise-grade capabilities which are not available on Cloud Foundry. So those are commercial things, meaning that even though you can deploy Cloud Foundry on any IaaS of choice, you can pretty much achieve the goals that you are after, but certain things would be missing. And Pivotal probably did a good job by filling in those gaps by providing the necessary services such as single sign-on extension, application manager UI. It's a web-based, browser-based UI for driving your deployment. You can develop your own, but probably your expenses and your costs of creating those add-ons would outweigh, I don't know, would be much too expensive for you. So you would be better off to just go with what Cloud Foundry, Pivotal Cloud Foundry offers you. So they offer you API gateway. Auto-scaling is a great feature. Mostly on IaaS, you can provision that capability on your own because it's available. So the system would have like a hot spare, the hot instances in a standby mode, and whenever you would like to scale out, you just borrow from that pool of available resources. And it's specific for any cloud platform. PCF does a good job in this department, so they provide auto-scale. So you just specify the range of the instances you would like to have available, so that if there is a spike in user activity in the traffic that is driven towards your applications, the system would transparently, elastically provision those instances. it's just a big boon. It's just a big benefit. Again, you can do it yourself, but probably it's not worthwhile. It would be much more expensive. So bundled software, they already have some of the runtimes, like whether it's relational databases like Redis for caching and others. And those pieces of software are available to you for provisioning on demand. You can say, I would like, for example, Redis because I need a caching solution, and the system would do it, and you just need to specify it declaratively. Lots of things is happening through the command line interface, even though you can provision it through application manager, which is available if you use PCF. And then it's a very nice way to script your environment. You can build it from the bottom up to the levels that you need. And the good thing is that the same exercise can be repeated on another. If you have decided to migrate your deployment to another cloud vendor, you can repeat it. You can recreate it. And so it's pretty much lots of housekeeping, system administration work, or DevOps work has been much simplified. You have lots of support in this regard. Spring Boot and Spring Cloud Services, it's for those people who work with Java, Service Marketplace, and extensions. Everything starts when you deploy Cloud Foundry on the cloud vendor of choice. Of course, you need to notify the target cloud vendor of your intention to deploy PCF, because it's really kind of it's a big thing. It's not like you provision 5 instances. You would probably need to write an email and get that probably a discount, or essentially notifying them that you are going to run a very kind of a very large, big footprint platform on top of their cloud. So after that, the next step is to partition your PCF cloud into organizations and spaces. It's just a way to organize computing resources logically. So organizations is the top at that organizational hierarchy. Below it are spaces. So spaces are created within an organization. Organization can have multiple spaces. I believe organization cannot have another organization. So that's probably be an overkill. And when you do so, when you're doing so, you need to align. You need to add some kind of a meaning to what you're doing. So usually people do alignment of the organizations in the cloud as per the real organizational structure. So you might have like marketing organization, sales, and essentially it's just look at it as if it's just computing resources available to the marketing folks, to the sales folks, and the isolations. The isolation boundaries are extremely strict, so kind of people from sales won't be able to see what's happening in marketing. It kind of creates those anti-corruption layer, like Eric Evans' domain-driven design is like implicitly implemented here as well. And then you can, within those organizations, you can create spaces, and usually those are more technical. And you might have dev, user acceptance testing, maybe production integration, and whatever the case might be, and this is specific for your problem domain. Okay, so it's an important step. Buildpacks, that's where Cloud Foundry offers you a great deal. And it really speeds up your development life cycle. So you become really agile because you don't have to bother about, I don't know, bundling runtime with your application. And if you use IaaS, then, I don't know, just installing that runtime of choice, or have a specific flavor of like machine image which would have that runtime. So lots of options are available, but PCF takes it probably to the next level of ease of use because those Buildpacks available for a quite wide range of common runtimes that you can find in everyday work. So Buildpacks essentially, it's a collection of scripts that when you submit your applications, they perform introspection of your bundles. They're called droplets. Just think about them as just zip files or jar file, if you will, which would contain certain artifacts. The system is smart enough to look at certain artifacts, and they have built-in heuristics which allow them to intelligently figure out what your application really needs, what kind of a runtime. Right? It looks at certain things, and you can specify that you would like even to have a specific version of, say, Node.js runtime or Java, right? And Java also is provisioned with Spring jar files. Ruby comes with Rails and Sinatra. And take a look at these common IaaS admin tasks that are transparently handed by Cloud Foundry. It's not all of those, but I guess these are the most appealing ones where you say, yes, that's kind of a very big win for us if we can provision a VM by just doing it at command line. So I would like my application to have the underlying VM with so much memory and virtual CPUs. You can also, on demand, provision a number of instances of that specific type. So the system would replicate as many VMs or as many containers as you wish, given that you have the quota on it and you don't really exceed your available resources. And this is done transparently, meaning that the system would just require you to give a notification. This is done through the command line interface. Of course, the same thing can be achieved on Amazon, on Google Compute Engine, and what's not. But this API is uniform. Now that's the key factor, meaning that you don't need to learn, I don't know, like AWS command line tool, ditto Azure, and what else you IaaS you would like to use. Firewall configuration is done. Also, you have some options to open ports, close ports. It's not as elaborate as you would find on a specific IaaS, right? But nevertheless, it's powerful enough, and there are certain extensions that you can use to make it really powerful. Okay, so configuring load balancer. Load balancer is usually some sort of appliance that sits in front of your instances, and it allows you round robin or least recently used or whatever, least used node, whatever kind of a policy you would like to apply. And again, this is done transparently. There is no involvement on your part. And it's very robust because the way PCF handles infrastructure, it always adds redundancy. And that redundancy is added on top of what IaaS gives you, meaning that your application is becoming more robust. That's the key factor. We're not kind of talking this. I don't believe that it's anywhere in the slides. But the thing is that there are 4 layers of high availability that PCF offers you at kind of a very low level up to a very high level, meaning that your application, if you deploy it within PCF, would be more robust compared to just a plain vanilla IaaS deployment. Even though, again, if you are very familiar with the tricks that you can play on a particular IaaS platform, that's fine. You can probably create some sort of a script, so you can leverage certain high availability services. But again, it is a vendor-specific API, vendor-specific skill set. And you need to avoid this. And that's what people are kind of moving. People want to decouple themselves from those details. And currently the problem is that there is no standards, no cloud standards. People are trying to emulate maybe Amazon, maybe kind of use OpenStack as some sort of open kind of source API. But it's still probably it's not going to materialize, because for cloud vendors, this is really kind of a crown gem for them. They really want to stick to what they do, and they want to kind of maximize their profits by attracting people to them and having them kind of stay on their platform. PCF allows you to feel that have a sense of freedom, that you can actually lift and shift your application without having to learn a new API for lots of things. And that slide reiterates the point that you have lots of hidden benefits. And again, I'm not selling anything. I don't want to sound like I'm selling you like a used car. It's just up to you to pay attention to those details, which might not kind of immediately register. So there is a question: assumption of common IaaS admin task PCF handles. Then would it be also robust monitoring logs on IaaS available? In terms of monitoring logs and everything, PCF wants you to stay with them, right? So they essentially expose you through certain endpoints where you can connect different nozzles. That's what they call them. It's just some adapters that allow you to stream your data as a stream of events into any persistent storage, or just to console, just dump it everything on system out. But the point is that you would have a skewed picture of what is actually going if you really go into the IaaS, because PCF insulates your applications within its own environment. And you'll probably be able to get a sense of how much PCF consumes of local resources. Probably by the end of your billing cycle, you'll have a bill listing all the resources that have been consumed, and that would probably be another way to see what's going on. Okay, so including the ability to evaluate costs being spent. That's Amanda, that's the right question to ask, because now you have to be aware that you pretty much sitting in a car, and that car kind of drives you, but you have no kind of a sense how efficient the car is. What would be the appropriate way to handle? Shall I drive as fast as I can, or maybe as slow as I can, or maybe there is this optimum speed limit. Usually it's kind of 80 kilometers. So if you do 80 kilometers, the way engines, that injection system works, that 80 kilometers is the most economical mode of the speed and the driving habit. So for that, you would need to evaluate. So I kind of have a feel that PCF would probably be rather expensive for you. You will need to kind of do lots of housekeeping, shutting down services if you don't need them. And again, if you really want to start using it, proof of concept. So do it, see for yourself. Definitely IaaS, if you work natively on that IaaS, you will be in a much better position because you will be using directly the native services, that managed services, which are available to you. Okay, so you need to perform that analysis. It's very difficult to do without really understanding the runtime profiles of your applications and how PCF actually handles it. Even though I understand that if it would be very expensive, very costly to run your application on PCF, you will probably be disillusioned and you will probably drop out altogether. Okay. Command line interface, that's where I guess you need to spend some time to become proficient. Command line interface touches all the points. It's quite extensive because PCF, even though we haven't discussed all the components and services, is quite elaborate. Even though lots of services are hidden from you, but in order to become, I would say, intelligent sysadmin or DevOps operator, you need to familiarize yourself with that tool. Certain things can be duplicated in that management console that PCF offers, but not everything. CLI is the final thing. And the other problems that I found with the admin UI, that it's not quite responsive. You need to refresh the page to get certain things. Maybe they will improve it in future versions. What I would expect is like in Excel, that reactive programming. So particular cell in Excel changes, and that change should cascade the changes across your spreadsheet, right? So that you've got UI up to date, and certain things just kind of fall through cracks. And command line interface, it's just unavoidable thing to do, but you have to learn it once. Again, let me reiterate, it's a repeating theme that essentially you learn it once and then you're done for the whole career. By the way, Cloud Foundry and Pivotal, they have that concept of roles, as you would expect in any enterprise-grade system. So you can be a manager for a space, you can admin who can do anything, and there are some restricted roles that you can expose to maybe certain folks who are not supposed to do. Just observe that least privileged access principle. An example of CLI commands. CF is the tool name, and we've got, I guess, 4 various options of using it. The very first bullet, we have an application which is packaged in the zip file, and that application sits locally on the machine from where you would like to upload. It can be any of the machines in the cluster, or it can be your local machine, but you need to establish, you need to log in first to be able to do that remoting operations. So P is a path that's local, and then in most cases you will be doing just SDF Push. Push is just to take that zip file and push it to the cloud. Lots of things that if you look at the sequence diagram of things what's happening is just like really staggering, mind-boggling. And lots of things might go wrong, but the system is robust enough to provide some redundancies where any failing node of the infrastructure is duplicated, and it will help you push that zip file to the destination where it would be just deployed. So we give it a logical name, My App. My App is what you will be seeing in command line or in the admin UI. You specify the memory. If you don't specify, if you don't give those details on memory and disk space, then some defaults would be given, which is not a good practice. First, you need to understand runtime profile of your application. So when you do so, you kind of get that affinity with your application. It becomes your baby. Because don't use default, because lots of demos for PCF is about CF push, kind of you're pushing, but you pretty much get yourself into a disadvantaged position where you consume lots of resources. Probably the system will figure out that this guy needs a bigger machine, and it will cost you more, because like what Armand asked like a couple of slides back, or one slide back, that you need to be aware that that's kind of apparent ease comes at a price. And if you don't spend some additional time in trying to fine-tune your application just to provide enough RAM, for example, here we provide 64 meg. If you don't do this, probably the system would provide you half a gig. And it would be a different flavor of virtual machine, and the system would probably be much less efficient. So in this way, you document that 64 meg. Of course, you can exceed it, right? You can have out-of-memory exception. But for that, the good thing is that you can test your application outside of the cloud. Run it locally, do some monitoring, profiling, and see the memory consumption, your heap hidden, and what's not, right? -K, it's a flag for specifying the amount of disk space that you would like to be provided. So if you would like to do some persistence locally, again, avoid it because it's ephemeral. Okay, so that's the first command, viewing applications logs. So that's a way to dump the output from the system to your terminal. And you just specify app name. It would be my app in this case. You can tail it by specifying the recent flag. And what's interesting, if you have a cluster of machines, that log would be consolidated. So pretty much you will be out of the water, and probably you will be overwhelmed with the amount of information that you receive, unless you have a very fine-tuned logging saying only output errors or warnings. Just don't give me any tracing or debugging. This is just very primitive, the very kind of first thing that you would look at. There is a number of ways. They're more complicated, where you can take those event streams. Every event is just a log message, and you can send them to a specific designation. It might be any relational database, a caching system, or you can just make them available through a RESTful API where external service can connect. Okay, there is a question. In the SDF Push command, can you show which is organization and which one is environment? Yeah, Mohammed. When you start using it, you have to log in first. When you log in, you specify the organization and the space. So when you log in, you're pretty much locked. That's your sandbox. You cannot really step out from that boundary, step over that wall, and just say, okay, hey guys, in the marketing, what are you doing here? Right, that's it. You are insulated. And you can only see those resources that have been configured, provisioned in that organization, in that space. Pretty much you are limited to a space. Okay, so it's a cell from which you cannot step out. If you would like to access another one, you need to log off or start another terminal session, connect, authenticate yourself properly. There is a number of ways to do that. When you do, you are in that particular space where you logged in. So that's how it works. By the way, guys, as I said, we will have a break, short break at the top of the hour. Probably in about 7 minutes. We will break for maybe 7 minutes or so. And as you see, these commands can be scripted. These commands are very easy to remember, maybe except for -K. I'm not sure what it's kind of what it designates. maybe just leftover from the original experimentation with the kilobytes of disk space. So creating service from a CF marketplace, that's kind of a worthwhile spending some time to explain what's happening. Again, CF, we give it a name. I would like to use a cache, right? I give it a name. Create service is that subcommand. So CF operates on those subcommands: push, logs, create service. Marketplace gives you a list of those services that are available, like MySQL, for example. Redis in this case, or it may be RabbitMQ for messaging. Redis, it's a Pivotal version of Redis that you can deploy. But what's interesting, Pivotal, probably it was their marketing who wanted to kind of monetize a little bit in this direction. They give you a flavor. So that shared VM is just, it's a plan, if you will. Kind of bronze plan, golden plan, and what's not. It's just a way to say, guys, if you would like a more powerful, more robust system, you'll have to pay. It will cost you extra. But shared VM, it's just a way to deploy Redis on a single container. Probably it's very scaled down, and it's probably not very robust. You can specify, I guess, enough memory to accommodate lots of cache data, but it's not very robust. It's a single VM, shared VM, and pretty much there are other options that you need to go through to get the best option for you. If it's not critical, probably you can go with least expensive. If you need something robust, you'll have to pay extra. And now take a look at how you would scale application. Scaling application, CF is missing here. You take the app names that you deploy originally, and now look at this beauty. You just say how many instances of that application with all the software stacks, with all the kind of a configuration to be replicated. So you pretty much can scale a running application. You can specify the number of instances that you expect to provide enough support for the incoming traffic. Also, you can specify the memory if you would like to increase. So we're talking about with -I you achieve scaling out. With -M you specify kind of a scaling up. You provision more memory. I'm not sure if the current version of PCF allows you to specify the number of virtual cores. I guess that detail is probably not available, but it might be because they're in a kind of flurry of development. Lots of things is happening. It looks like they're kind of getting a good time because lots of people are using their platform. Okay, so moving to the cloud. So that's kind of a new topic. We are moving from our discussion of PCF to moving to the cloud, where we will talk about designing applications. But in certain cases, I will be making some references for you to kind of just connect the dots so that you can see the bigger picture. So the question is for central admin teams managing CF. Is there a way to navigate within organizations' admin options? Yes, that's right. And again, Mohammed, the things work as follows. There is no such thing as kind of a wide open system, right? So it's closed. And in order for you to get access to organization's space, you need to log in. But then it wouldn't be command line, it would be that nice web UI. So when you log in, at this point in time, if you admin with kind of a super kind of a super user kind of a root, you can select organizations and organizations within and spaces within those organizations. Yes, it's available in UI, but again, it's not available to everyone. You need to know that password for that guy, or that would be the only way for you to do. Okay, so UI is also protected. You cannot really log in as a space manager who has kind of a low-level privileges and then somehow elevate your rights. No, that's not possible, as you would expect it. So moving to the cloud. So what's there? So the lift and shift. So that's the I guess really the end target for many organizations. We would like to take our application, like as if you taking a suitcase of sorts by the handle and move it to a new room, to the new cloud. It's not going to happen like this for the most part, unless you have already designed your application using certain considerations for doing so. In most cases, re-architecture might be required. Okay, re-architecturing is activities that must precede moving to the cloud. In some cases, probably, if it's not kind of an extreme case, you can check your application and deploy it on IaaS. Okay, and that's fine. That's fine. And then you can start slowly partitioning your application, breaking it down. But most likely, you won't be able to run it on PCF. So application redesigning is required. So when you deploy your application on a particular target cloud platform, you need to take advantage. Pretty much it's an unavoidable step. You need to leverage the security and other capabilities from that cloud platform, and you have to align those capabilities with what you already have. You need to be aware that when you go to the cloud, lots of things might go kind of happen differently, right? There is latencies, there are failures, there is kind of maintenance windows, lots of things that you have to be aware. And when you have finally deployed your application successfully in a particular cloud, then you pretty much lock yourself out from other options. Most likely you would be running on IaaS of sorts, and if you would like to migrate to another cloud because there is a big promotion going on for maybe next year, if you move within the next month, you'll probably have a big discount. Probably someone in your business would grab that opportunity to move, and it would be a major headache for you. Okay, so there is a question. Hello, Atul. Yes. What are factors which need to be taken into consideration to select appropriate RAM while pushing them up? Run it locally. Attach your profiler, which would be monitoring the heap consumption, memory consumption of your application, how many threads, how many CPUs, pretty much how, is it CPU intensive, is it IO bound, just have runtime. But generally, profiler is the only conclusive way to do that. Right, and all modern tools, they come with very nice free tools like Java. I know .NET does the same thing. It might not be the case with probably Python or some other applications, but you can use tools that come with the operating system. So you can use Task Manager to see what's happening with that particular application, like the committed memory and some other details. Okay, so architecture modernization, it's a big topic, so let's take a break for maybe 7 minutes, and then we will continue after that. So 7-minute break, guys. Okay, guys, welcome back. Continuing. So architecture modernization probably is on the agenda of many solution architects, maybe enterprise architects, lots of people thinking about how would I go about modernizing my application. It happens, every like 7 years or so. Let's do SOAP, let's do REST, let's do something. And cloud modernization is probably no exception, because moving to the cloud, it's a major effort. Probably it's one of the risky things that you have to take care of before kind of a major disaster might happen if you don't do things right. So one of the key components here is to start using the microservice-based architectural style, or MSA. You've heard about SOA. So SOA is just old-fashioned way of doing things in distributed fashion using web services. And microservices just take the same approach, but they do it in a more practical terms. Right, microservices are supported by lots of technological advancements that had been happening since SOA. SOA is considered kind of a bad word now, but the principle was right. It's just implementation kind of lacked some consistency. Essentially, you created monoliths talking SOAP. Right, and microservices, they practically, in the practical aspect, requires that you provide containers, that you adopt a RESTful style web type of integration, micro UI, which we're going to talk about shortly. So all those things, they pretty much make MSA or microservices a more viable, more, I would say, more technically feasible solution compared to SOA, where it was mostly about just declaration. Right, and as a side effect of that approach with microservices, you can start thinking about that operational agility, and new roles appear, such as DevOps. You have benefits in terms of getting scalable solutions, faster provisioning cycles, and lots of feasible, practical things that have never been on the agenda of SOA practitioners. So monolithic applications, we are familiar with that thing. So, but let me just probably walk you through quickly. So there is lots of criticism of monolithic applications, as if it's just kind of a big mud ball of code with lots of kind of components, big footprint, but at the same time, in many cases, it's just unavoidable. So I worked in banking and insurance company on online presence for quite a long time, and I know that it's just impossible, and it's just counterproductive to create lots of services kind of talking to each other and just have very nice look on the diagram. But in fact, when the rubber kind of hits the road, that's just all bets are off. You have to create those monoliths because they give you that security control because the security perimeter is limited. You have high performance out of those systems because you need to have kind of very short path integration between different components, and you are better off to incorporate that jar file or that library within your runtime. So it's kind of dynamically loaded, and it becomes part, and everything is happening in the same process image on the same heap. And you potentially might have some transaction semantics, which kind of permeates all your technology, your kind of software stack. And here, the shorter those kind of paths links are, the better, right? Generally, it's a good thing. When you create a monolith, as long as you don't exceed certain thresholds, certain limits, there is nothing wrong with it. Ease of deployment, you have just one war ear or like any other bundles. You just drop them, and that's it. The system would kind of load it, and you are off to the races. So SOA, unfortunately, didn't think in depth, in the technological depths. It was more about offering some business side to things, where you would have that mapping. You would provide narrow services, specialized services aligned with your business capabilities, and all that kind of stuff is really good. But they never paid attention. Those people at the who kind of were promoting SOA, they didn't pay attention to the technical details. So there was no depth, and one of the negative side effect was that monoliths were kind of proliferating like mushrooms after the rain. And SOA was supposed to kind of set some guidelines, but those guidelines were not enforceable. So that's the problem. And in order to do certain things right, you have to kind of manifest it, and then you have to have certain mechanisms to make sure that that system works. Otherwise, it would be just, I don't know, wishful talking. Now, disadvantages are as follows. We've got large code base. So for that, you would need probably, if you have multiple pieces of functionality bundled in that deployment artifact, then everything is going to happen in the same on the same heap. And the possibility for a particular service to go rogue, to go out of control, might potentially bring down the whole thing down. So it's quite possible. So you've got pretty much 99.999% of the code working fine, but there is just one thread that just got out of control, and that thing would bring down the whole system down. You've got a tightly coupled system, and as you know, all that leads to problems for groups dealing with development, testing, and evolving the system. You have to, if you know, like specs, like large specs, like CSS, cascading style sheets, things like that, at a certain point in time, the level of entropy reaches a point where people just don't really comprehend what's happening. Right? You need to have that kind of a tribal knowledge to discover, okay, guys, how can we really have this room full of people talking at the same time and hating each other? So the best way is just to start partitioning. When you start partitioning, it's much easier to develop, test, evolve. And the resistance to change just magically disappears. So that microservices architecture style really promotes all those things. But in addition to that, it gives you that mechanism how to enforce. Right? And those applications are difficult to scale. So the list, that kind of list of complaints is going on. What's happening, usually you would bundle everything, not only from different lines of functionality, but also from different tiers. You would have probably JSP bundled alongside with your business logic, JSP Java Server Pages, or maybe ASPX. And everything is just kind of creates that big stateful application, because in order to manage that monolith, the best way is to create some sort of a state, right? And when you have multiple tiers or multiple pieces of functionality, it's very difficult to create some sort of anti-corruption boundaries, because everything is just blended together, unless you insert certain things artificially, which is kind of a non-organic for that application. So that anti-corruption layer or boundaries, again, it comes from that Eric Evans domain-driven design. So this concept is very difficult to enforce. And then also look at other intangibles, like more human-facing problems. It's more difficult to maintain the source, the version of changes of your code. It would create contention points, because people would be checking out code, and when if lots of people are working on the same piece of code, the chances of contention increase, and you will have to merge the code, because usually people are using non-blocking version control systems like SVN or CVS or whatever you're using, not locking the resources because you want to achieve that agility. And the moment you check in your change, someone has already modified the code, and then you are left with the task of merging the code. And by the time you do that, someone else checked in the code. So it's just not a good, not kind of a good development environment altogether. Also, developers usually, when they're faced with that whole code base exposed to them, they become a little bit intimidated. So generally, lots of things that in one way or another transpire needs to be dealt with. And of course, you can deal with monolith currently without resorting to things like microservices, going to the cloud, or architecture modernization. And many people who are aware of the existing possibilities just take advantage of that. For example, layered architecture. When you layering your application in business logic, persistence layer, the front end, maybe you have some sort of separation of concerns through aspect-oriented programming, cross-cutting concerns. So all those things, they help you to a certain degree. Spring Source originally, remember that J2E without Enterprise development, I believe the book was without JEE. It was about dependency injection. It's designed by contract, and eventually JEE spec adopted that CDI component and dependency injection mechanism, which considerably reduces coupling between systems. So if you do that right, and if you know how to kind of combine those things with the nature of the application, you can achieve a great deal of decoupling, meaning that you have a monolith, quote-unquote, type of application, but it's easy to evolve. It's kind of a layered. It's more it's easier to evolve the application. But a more radical step would be to just move towards an MSA, where that MSA would be one of the primary activities for successful architecture modernization and cloud migration initiatives. Because it's just, again, lots of things might go wrong. So let's talk about benefits and some of the disadvantages. The most obvious way to look at microservices is that it's a way to break up monoliths. Nice. Then MSA gives you a number of good things, right? So if you get services which are used in combination to provide the functionalities that you need down the road, then the change cycles for different services can be pretty much done in isolation and decoupled. You just provide versioning, and you just let the other parties be aware of the changes in the version. Then development cycles become faster because the changes are smaller that you need to do, and you can test them easier. And usually you test your microservice in isolation from other services by just providing stubs, kind of some mock-up services, and it's just nicer, more kind of deliberate working on a particular piece of functionality. You can scale per service per tier, meaning that if you have several kind of layers, you can provision more instances at particular layer or a particular service if you need be. So it's very difficult to say, okay, guys, I've got a monolith, I've got, I don't know, like a dozen dozens, let's say, different services running within the same thing, and I would like to scale a particular one because it's really a hot spot at the moment. It's kind of a red hot, lots of contention, but other guys are kind of slackers. They're just sitting there doing not very much. How would you scale that service? You need to scale the whole monolith, and that's the only way. In this case, you can scale it as per service. Small development teams, getting up to date. Okay, guys, here's what we do here. You can get interns, you can get people maybe on loan from other groups, and they can get up to speed in a much faster way. So microservices promote stateless type of design. Usually, you might see that some people promote that there is a persistent store attached to a particular microservice, which is probably one of those artifacts that might get in the way. It might go and bite you. But still, it's kind of easier to attach a particular storage for that external state at the microservice layer. When you start decomposing or breaking down your larger application, you kind of start thinking differently. Of course, it's a major investment of time and resources, but the output of that exercise is very beneficial, because first you have your application per modern and quote-unquote, whatever it is, standards, where it's partitioned. It's really SOA, but done based on some technological advancements with containers, with the way to kind of manage, orchestrate those services in a meaningful way. And all those benefits, they come at a price, right? But at the end of the day, when you have it, most likely it would be it will probably last you maybe another 5 years, maybe even more. You can always improve, like swap one service for another. You can add more services you might want to consolidate, maybe remove services. But generally, you created that ecosystem of software where you can kind of organically evolve it. And it also lends itself to porting to a cloud of your choice. So microservices cons, but before that, let's take if we have any questions. Can we deploy each service independently in MSA? Does J2EE allow deploying individual services? Can we deploy each service independently? Yes, and that's what's happening, but there would be definitely a specific kind of a window of outage when the service wouldn't be available. And usually what happens, this is a concept of hot swap, where you have this kind of a green-blue deployment. When the service is green, it's kind of a red, it's kind of a working hot, if you will. And then you deploy another service, which kind of sits somewhere on the staging, and then you pretty much have two services up and running, but the new service is not available. Microservice, right? But at a certain point in time, the router just routes all the requests to a particular IP address. And then you just, for a short period of time, you shut down the previous service and you have that stage service available as a hot standby. And when you essentially you need to allow the router to start routing requests to that new IP address, right? But the router just shields your service. And that's what, by the way, PCF does transparently. It supports so-called blue-green deployment. There are certain things which can be automated using PCF, which allows you to do exactly that, got a hot swap. But PCF requires you kind of to do all that kind of MSA type of things. And not sure if I understand the question. Does J2EE allow deploying individual services? Of course it does, because any WAR file or any ER file, we're talking about Java Enterprise Edition, they support that deployment. And you can do all those things with, as long as you've got some infrastructure elements, such as, for example, load balancer. You can bring up new kind of a service, and then kind of have load balancer start sending requests to that new service. So lots of things, but it's kind of a more of, I would say, finding a good balance between the complexity and the duration of that outage. So it's nothing really, there's nothing bad about kind of displaying some sort of blob to your user saying the service is temporarily not available, please try again later, I'm sorry for any inconvenience, things like that. So it's possible. So the question is, do we need to use MSA to be on CF, or a normal Java app can be modified? Yes, on Cloud Foundry you can deploy your own normal Java application, no problem. Yes, as long as it's just doesn't have too many dependencies. Yes, you can deploy Java. It's just a regular Java virtual machine where you deploy it and you run it. That's it. Yes, Java application. I got it. Yeah, Navin. You can do it, but again, start thinking about MSA, which kind of eventually you'll end up doing it, and the earlier you start, probably the better. Okay, so one of the advantages of Monolith was the very good performance. And by the way, some brokerage companies, they have deployment. They moved from C++ based code to Java because Java, if done right, can be extremely performant. With just-in-time compilation, it essentially becomes as fast as native code. It just vectorizes operations. It pretty much compiles code into native code, right? And it provides that kind of a switch to the native code when it's needed, right? So Java is a very productive tool. And Monolith benefit from this. If you go with microservices, essentially you have out-of-process communication. It's not in process like with Monolith. And at this point, all bets are off. You can have like 2, 3, maybe 4 orders of magnitude more slow communication, right? You have to just rethink how you communicate. Maybe caching would help you. Maybe just not using HTTP, just using socket connections. Maybe some other tricks. But just be aware of that. Overhead, you have to orchestrate deployment, right? Back to Amanda's question. So how? So what is actually involved generally? You have to manage that environment. You have kind of a crowd of those services. Hopefully it's not a crowd of cats, you know, like a herd of cats that you have to manage. It's more of a kind of you act as a conductor of a symphony orchestra who is trying to really move things in a nice orchestrated way. So DevOps practices is the common response: automation, scripting, packaging, all that stuff can be done. But again, you have to have that skill set. You need to have understanding of the overall composition of your application. And Pivotal, for example, gives you Buildpacks for provisioning dependencies. So in many cases, lots of things have already been incorporated as a best practice of DevOps. You have dependencies, and those droplets, they would, when you deploy your code, it will be supplemented with all those dependencies as needed. And then for monitoring, there would be that log aggregator capability. Part of it we saw with that CF logs command line, but it's much more than that. So if you really want to get enterprise-grade logging capability, log aggregator is that subsystem of PCF. Anti-pattern, some people go really overboard. They start kind of achieving an even finer level of granularity. They kind of say, okay, it's probably still monolith. So that guy probably would be kind of beyond kind of once, and kind of now is kind of trying to apply that kind of a knowledge that the person learned once to all the possible scenarios. The critical I guess threshold to observe is that if the maintenance of that service begins to outweigh its practical usefulness, that probably would be the threshold below which you shouldn't go. It's considered an anti-pattern for a good measure. It's called nano-service. And usually you would have some common sense, kind of a whole sense, to say, okay, guys, it looks like we already have. Or another, I guess, heuristic would be, in addition to that practical usefulness becoming really kind of not really realizable, is the count of services. If you have too many services and it becomes more difficult to bring up the whole orchestra at the same level, then probably you need to consider some sort of integration. So even though it might be a little bit of a mechanical thing, where you would just combine, build a web application from kind of a different services, it's kind of a way to move up towards monolith, but you need to consider all those things. So it's a kind of a science and slash art, the way you want to look at it. But again, the thing is that with microservices, again, this word, that's kind of a technology label is a little bit misleading. Like, what is microservice? I guess some folks, like Martin Fowler, they were very active at promoting, and they can coin those terms faster than we can consume those. Right, so microservice is just a way to say the way I look at it, it's just a micro means that it's kind of a more technical, right? That's aspect. Microservice, milliservice probably would be not appropriate. Kiloservice, again, microservice is a good kind of a word. Some technology folks have a very good thing for coining, like NoSQL, whatever that means. So the question is, how is Droplet different? How is a Droplet different than a Docker container? Droplet is your bundle. Think about it as your artifact, which contains your application and some dependencies, and you can deploy it into Docker container. So Droplet, it's not a container itself; it's a code that gets deployed into Docker, as well as it can be deployed on a virtual machine directly. Okay, so microservices interconnectivity. So a couple of slides would list certain technical details, which might give you some, I guess, insight. Maybe you are most likely are familiar with most of those, but just let me just recap. Microservices, they borrow a great deal from the old-fashioned SOA, and that interconnectivity approach adopted in SOA to use technology-agnostic protocols has been successfully borrowed. Right, nothing wrong with that, and that's kind of a good thing. So HTTP is a transport of choice for interconnectivity, with kind of one big twist is to drop using web services, SOAP web services, in favor of RESTful style of interaction. And RESTful, as you know, that Harding's PhD dissertation was about creating stateless RESTful services, right? But many people kind of improve on it, quote unquote. So some state is being still passed. And generally, RESTful is the way to go. It's simpler, it's more intuitive, it's faster than SOAP. It's much easier to do, like SOAP with attachments and things. So asynchronous communication plays a very big part in it, because when you go in a distributed way and you would like to maybe conserve, kind of not hold, you want to prevent holding your clients hostage of that kind of a distributed architecture where a person should wait until the whole orchestration happens, and potentially it might take several seconds, right? And the person is sitting there waiting for the acknowledgement. So pretty much it's RPC, kind of a synchronous call. In some cases, if the business warrants, the business process warrants, you can acknowledge, okay, we received it, probably you just persisted locally for like short duration time for several milliseconds, and then you send a notification, yes, we've received your request, thank you very much, and then you launch the whole thing, and later on the person would receive a notification and acknowledgement, yes, we have successfully processed your request, or otherwise, sorry, we've missed certain details, or there was a problem processing your request, and pretty much you would need to compensate for that unfortunate situation. So asynchronous communication is a very rich kind of set of ways and techniques that you can use. Lightweight messaging systems, very popular, RabbitMQ. By the way, RabbitMQ is available on PCF as a service that you can deploy. And the move is towards leveraging wire-level protocols like AMQP for interoperability, because many systems understand AMQP. It doesn't matter what language it's written. And that's, by the way, a way to start looking at why do we use JMS, Java Messaging Service? Because I'm kind of coming from the Java kind of a shop. I worked with Microsoft, but Java was my recent kind of a thing. And people are stuck with that set of technologies and specs as defined in JEE specification. And JMS is there. And you can do the same thing with much better, I guess, results if you probably drop it in favor of other things. So it's up to you to decide. Okay, so non-blocking, not RPC-like remote calls are supported through using Ajax, WebSockets. So WebSocket has become, I guess, standard. It's supported by all the browsers, modern browsers. Many application servers, they support WebSockets, meaning that you can create bidirectional channels of communication. And WebSockets, they also support reactive programming design pattern. So that's another thing which is kind of sitting there, not very attractive, but reactive. Really helps you create very responsive, data-driven type of applications, rich applications where the client would really appreciate, right? So as you see, microservices would give you all that because essentially, if you would like to, say, enable WebSocket on a particular application server, right? Or you might say, you know, WebSocket probably not a good idea. It would create some maybe security hazards or otherwise not desirable. We don't want to enable that capability, as opposed to maybe saying we've got a service which really benefits it outside of other services. So let's deploy it as a separate microservice on Tomcat, which would support that WebSocket or any other asynchronous communication, maybe using Ajax and what's not. Okay, so microservices give you that fine-grained control over your application. Okay, so data exchange is important. Data exchange, by the way, in many ways can help you achieve interoperability without going with web services, because for many years, I guess big application server vendors just ingrained that kind of indoctrinated that concept. Guys, interoperability can be achieved with SOAP web services. And for that, you have to buy this application server, which already comes with the pre-built support for WAS security, WAS transaction, WAS star type of specification. If you kind of disentangle yourself, if you kind of shed the shackles of that kind of mentality, and you start looking at what can be achieved in other ways, data exchange at the data level, working at the data level, interoperable scenarios, you can achieve that. So essentially what you need to do is just adopt some of the data interchange formats like Google Protocol buffers or protobufs, Avro, JSON, and maybe XML on a much lesser scale nowadays. And what's happening here, if you have adopted this as a kind of a standard in your organization, then it doesn't matter which language you use. It can be Go. By the way, PCF was originally written as in Ruby, and then they realized that the Ruby is just not there. It's difficult to maintain. It's easy to start, difficult to maintain. So they switched to Go. Go was developed by Google. Golang is extremely powerful, infrastructure-oriented language. So you might start looking at it. It's just many people started using it, and all those languages which understand those interoperable data interchange formats, they can pretty much exchange data. It's like what Google does in their infrastructure. They've got several languages that they have adopted as the standard. So they've got Python, Java, C, and Go, and they use protocol buffers to exchange data by just using sockets, send the data, and process data. Right? You just need to read that kind of descriptor of what the data is. Is it an array? Is it an int? Is it a string? And then unwrap it, read the data in raw format, and that's it. Okay. So AMQP, as we mentioned, is one of those. Micro frontends or micro UI, it's a new concept, but I've seen that we've been working with one bank, and we were kind of pleasantly surprised that they have adopted this already as the underpinning technology. So they use essentially macro UI to create that new age type of portal, where the portal concept, where you have pretty much that fabric, like dashboards, the UI facing the client with different pieces of functionality inserted as if it was just part of that UI, but in fact it's just a different portlet. It's a different component of your overall system. And portal is just a way to visually collect all those things with uniform UI into that nice, consistent client-facing fabric. And macro UI just takes it to the level where essentially you start thinking about micro UI with microservices as a new way to modernize your applications, right? So that single-page applications like AngularJS JavaScript library is a way to help you build those to compose. That's a suite of features. JavaScript is extremely fast, extremely powerful, particularly with the extensions with Java 6, with the compiled version of new technologies of building type-safe JavaScript applications. And when you combine micro UI with microservices, you have very nice blueprint for breaking up your monolith, not only at the back end, but also on the front end. And now you have those kind of small per feature development teams, right, where they operate and they're responsible from end-to-end business logic. Essentially, starting from the whatever client sees in their browser, the JSON document which goes through a particular AJAX call through RESTful API, and then that it's kind of directed to a microservice, and the whole team, which might be kind of two-pizza team, maybe 4 people, I don't know, 6 people, 8 people, with business analysts, with everything, would be responsible 24/7 for maintaining end-to-end and the persistence layer. Pretty much you have this kind of cut through the whole application from all the layers, all the tiers, from left to right or right to left, the way you want, and you're responsible. Things are insulated from each other. you achieve a level of development agility that you are really interested. Okay, so that's kind of a thing that nicely play together to create that new experience for developers as well. So let's quickly touch on the 12-factor methodology. Some of you might be familiar, others not. It's originally it was developed by that methodology was developed by contributors, or those who worked on the Heroku PaaS platform, and they shared it with the world. It's not kind of a rocket science. It's just some of the rather straightforward things. Just don't do it or do that because it will give you some benefits. It's just a kind of common knowledge shared, which is a nice way. And the good thing is that it doesn't really apply to a particular language, platform, or cloud deployment. It's just a way to start thinking that those principles might help you. If you look at those, you probably would say there are 12 principles, 12 factors, and you would say, you know what, I know this, it's just no-brainer, so tell me something I don't know. But I kind of put together a subset of those, like select 12 factors, 6 factors, which are more or less kind of different from what you would expect and what you would commonly want to see. So a configuration file is gone because you need to, it's called kind of a store config in the environment, which essentially is just a way to say inject configuration at runtime. And by the way, PCF does it. So if you want to change configuration, you don't need to promote the config file, which would kind of, there is no JNDI, there is no, all that kind of a set of technologies just magically goes away. What you need to do, you just need to specify what you would like application to see. And you can pass that configuration from command line. You specify it as a configuration file, JSON, and that JSON would be injected. It's like when you start, like you shell a bash session, so you fork it, and essentially it inherits everything that the parent had. And you can like set environment parameter, launch, fork that script, and then the script, if it's interested, can read that particular system parameters that was exported to it. So that's the way to communicate, and that's one of the more interesting things implemented in PCF, and that's kind of makes it make lots of technologies just redundant. Processes should be executed as stateless. Nobody argues about it. Port binding is just a nice way to say, okay, guys, I don't want to know where it is. It's just I want to know the IP address and port number. And I expect that that thing would be plugged in for me to use. Disposability, it's kind of a thing which relates more to actual resource provisioning, like robustness, a fast startup and graceful shutdown of your application. But it's not about application. It's about the containers. It has kind of a duality to it. Your application should be ready to withstand that fast shutdown. You essentially set a kill -9. You kill it, and your application, it doesn't matter, because if it doesn't have a state, if there is an in-flight transaction and the application was killed, there is no way to survive, to save it. But you can always pick up if you have a very short, fast startup time, because your application is small footprint, meaning that Docker container or virtual machine with a smaller footprint can bring up your application much faster. And when it happens, meaning that that window of unavailability is very short, and your clients would probably tolerate that. Okay, and graceful shutdown, meaning that you cannot really have kind of a leniency from the system to let you like clean up all the resources. You need to have a way, if you get something important, immediately persist it in an external storage, and then start proceeding. If you cannot do that, you get killed. Another guy, another soldier kind of stands up, picks up that load, goes to backend, reads that state, and starts processing. So the client would probably have the impression that something just happened, but it was kind of a little, a small disturbance in the cloud. So that disposability is really about microservices. It's about containers. It's kind of a vaguely formulated. Dev prod parity, again, tells us something we don't know. But now in the cloud, using PCF, you can achieve that parity. Essentially, you can do development in the environment in the same way as you would do in production, because you pretty much deploy the same code. You just say, I'm deploying in a different space or in a different organization. You kind of have all the tools that essentially help you to achieve that parity. Logs, treat logs as event streams. So what it means exactly, it's just a way to say, if I have this mental picture that my concept of what the logs are, then I can start sending those events to an external system, or I can provide a trigger to that event. If I have an error, there would be a parser of some sort. It's kind of a, clouds currently they implement that serverless architecture, kind of lambdas or functions, which is essentially a piece of code which you can attach to a particular event in the cloud, like an insertion of a record in a NoSQL database, or some failure, or reaction to a particular, maybe load balancing event. It's a good productive idea, very scalable services, very robust. You express your code, your intention in very small, several lines of code, and logs can be treated in the same way. It's just a matter of naming it differently, like event stream. It's the same message. It's the same log entry that goes through, but now you can have an application which kind of scans all those things for certain tokens, for certain things, for fraud screening, fraud analysis, real time, or checking for the robustness of your application. Okay, so I believe that's the last slide. So we'll have time to take Q&A. Questions. What composes browser view with microservices snippets? Sid, you can look at AngularJS. So you are referring to this slide, I believe. So AngularJS supports the single page applications, where essentially you can have routes, you can have different things which can be dynamically changed. It's data driven. It's just one of those things. Currently, JavaScript has a number of libraries that support that micro UI, and generally you can think about it as have a section of your HTML exposed as a div section of some sort, right? Kind of like a block of under your real estate on your page, and from that, if a person clicks on something or enters something, it would generate an AJAX call to the backend. Essentially, the response would go back, and it would react in that div section new content without affecting the remainder of the page. Okay, so that's the point. So the question is, Red Hat OpenShift seems to be a similar PaaS offering to PCF. That's correct. Yeah, it's a true statement. That's correct. Yeah. Could you highlight some key differences, pros, cons between the two platforms? Alexander, I cannot really comment on this very much, but the concept of PaaS is very similar. Because OpenShift does orchestration, and probably OpenShift gives you a better kind of orchestration. It has the backing from the Red Hat. PaaS probably not that much of, doesn't have maybe that technological orchestration. So I don't have much experience with that. I know that they're similar. That's it. Does PCF support containers like Docker? Yes, they do. They support VMs. They support Docker. Is an ESB still suitable to use in MSA? Actually, that question probably requires some discussion. The way I see it, ESB is a good thing, right? ESB, like maybe even MuleSoft or WebSphere MQ or other things, because it allows you to manage a number of things like routing, do smart routing, protocol conversion, some persistence screening, some cross-cutting concerns for security, maybe some injection, enhancement of requests. I believe that there should be some, I guess, good balance between the ESB. ESB can be positioned as some sort of aggregate technology. It can be some sort of microservice which acts as a hub of some sort. It does routing. It has some smarts to screen, like if you need to have a security, like a cross-cutting concern, the best way would be to send it through one microservice which would be responsible for screening data and then send it further down the road. Why not use ESB? I guess MuleSoft, I worked with it a little bit. I find it's extremely versatile because it supports multiple, I guess, endpoints, like file-based endpoints, like you can get file from file system or FTP, HTTP, mailing, what's not. So it's just up to you what balance you would like to achieve. But ESB, some people just kind of deprecating, saying no, it's kind of a big box of spaghetti. I guess ThoughtWorks were very good at kind of deprecating that technology before they started promoting microservices. So they wanted new. It's just my take. They were looking for a new consulting frontier, and so they decided deprecating ESB. ESB, I think, if done right, can help you a lot. And generally, the common look at things that is kind of has some sustainability is don't discard technologies, don't discard XML, don't discard relational databases in favor of NoSQL. It's just a matter combining new technologies, assimilating new technologies, and advancing new ones. So generally, the principle is and. If you say, should I use web services or should I use ESB or anything else? Or is it's exclusive. It's just us or them. You should kind of adopt that and. We should use this and that if the use case warrants. It's kind of not the answer, but I guess you know where I'm getting at. Okay, guys, more questions? That's all the slides that I've got for today. So web-based solutions offers a 2-day class on PCF if you're interested. Lots of labs you'll be pretty much doing. It's for designers, for solution architects to see what PCF can give you. Okay, guys, if there is no more questions, I would like to wish you every success. Okay, Joseph, thank you. Okay, guys, thank you for participating and making it interesting because questions were really important, right? Okay, all the best. Bye-bye.